morning. I am Joseph Neil Tuazon, one of the engineering managers here at BillEase. Today I will be talking about some high-level development strategies we use in BillEase to scale and develop our applications. First of all, I just want to bring this out. Performance doesn't equate to scalability. So for the longest time, Python has been criticized for its performance and speed on benchmarks when compared to newer languages like Golang or Rust. Even so, in Python, we still use and will continue to use Python as our main programming language. Being able to scale doesn't mean that we need to use the flashiest programming language. As a developer, I believe that proper system design is more critical than having the fastest programming language on paper. Given that, I will be sharing some development strategies that we use to augment Python to keep our system scalable and maintainable. Okay, but before all that, let's look at BillEase by the numbers. By the way, these numbers I'm going to show here are all publicly available. So right now, we currently have more than 5 million plus application downloads, both on iOS and Android. We currently are integrated to 10,000 plus merchants all over the Philippines. And we also have 40 plus engineers that make all these possible. So with all the active monthly users that we cater for, it's probably around 400 to 500,000 per month, depends on the season, if it's like holiday or a payday. And all the merchants that we need to integrate to and support for. And with all the impending features that this scale brings about, one question comes to mind. How do we deliver? So how do we make BillEase one of the most competitive and tech-focused platforms in the Philippines? Okay, so in order for us to do so, we employ the following development strategies in our engineering team. We have domain segregation. We have event-driven architecture, resilience and reliability patterns, and workflow utilization. These are some of the development strategies that BillEase uses in our day-to-day development. So for this talk specifically, I will be focusing on the first two, which is the domain segregation and event-driven architecture, given our current time constraint. So starting off with domain segregation, BillEase as an engineering team is divided into domains that make sense. So we have loan creation and repayment domain. We have merchant integrations domain. We have accounting and finance. We have customer support and collections. We have AI integrations, just to name a few. All these different domains are actually represented by their own team. These teams provide some level of separation where each team is context-bound. They have a clear set of responsibilities to follow. For example, the core BillEase team is responsible mainly for loan creation and repayment, while the CRM team is responsible for anything related to customer support and back-of-office operations. An AI team, responsible for making anything in our application shiny. Next one is reduce complexity with separation of concerns. Given that one team is only responsible for a particular business domain they are bound to, complexity in feature planning and development is greatly reduced. And lastly, well-defined context and reduced complexity leads to faster product iterations. So to make our domains more refined, in BillEase, we further divide our teams into sub-modules. We divide our responsibilities into different sub-modules whenever we see fit. So for example, my team, which is the CRM team, we currently manage a few modules here and there. Some of them are collections module, we have chats module, agent management, and so on. In this additional level of segregation, we are able to do the following: parallel developments. So modules are currently separated in their own code base. With this level of segregation, one module can be worked on and changed with minimal to no breakage of other modules or features. Next is more maintainable code base with loose coupling. With granular modules, we now prevent ourselves from falling into the trap of tightly coupling everything. With this, we intrinsically become more mindful of what we should and we shouldn't put on modules that we develop. And lastly, independent deployment and scaling. In BillEase, we currently utilize Kubernetes to help us orchestrate all the modules that we define. Each module has its own deployment configuration that is independent of the others. With this level of modularity, we can now scale only parts of our system without the need to scale everything else. So if module C here is currently on high demand, we don't need to scale the whole system. We just need to scale C and not A and B. So for us to better understand what all of these mean, I will be giving a very simple example of how this will work on any application level. Let's say you have this singular service with the following functionalities. You have getting clients with overdue loans. You keep track of all the loans that are overdue for collection, and you send a simple push notification. Pretty simple, right? Let's say business wants to add more to this functionality. Now, they also want to send us some SMS and some emails. So we need to add the actual implementations on the SMS, on emails, all of these in the current singular service that we have. Per brevity, I didn't put the actual implementation for them. But yeah, a few more functions. What's the harm, right? Now business wants to add more things to the logic. They want to add some model computation. They want to add dashboard analytics posting. They want to do more things. And our code base just becomes more and more. So if we are to list down all the responsibilities of the current service that we have, we can see that we now handle a number of contexts. For our simple service earlier, we now have all these different domains that we're handling, from client resource handling, loan resource handling, from notifications, model computations, and data analytics. Eventually, as features grow bigger as they are, as features get from 1 to 100, this kind of design gets more and more hard to maintain and to scale. So with the mono repo that we have, the first thing that we need to ask ourselves is, what groupings in this repo make sense? So here, with the current collection service, we separated the domains based on what we think makes sense. So from one big collection service, we now have a smaller collection service with the client service, the loan service, and the notification service. So going back to the example I have earlier, we now have this as the updated main flow. The change here is that most of the logic are offloaded to their own respective APIs instead of everything being in the collection service. In this example, we still get to do the logic of getting the clients, getting the loans, and recording them for future collections, and also doing the notification afterwards. The difference is that now what we only know in collection service is the schema and the entry point for these particular services. So now that we've talked about the basics of domain segregation, I just want to highlight why this works for Python. First of all, Python is expressive. Compared to other programming languages, Python has one of the most simple and intuitive syntax. Its English-like declaration makes it easy for us to declare our domains based on business requirements. So anything that your BA or PM can say or ask you about, we can definitely represent in Python. In this example, I've highlighted the syntax of Python as compared to Golang. Well, this is in no way taking a hit on Golang. I've used both programming languages. I just want to highlight here that Python is as simple and as expressive as it can get. So next one is on rapid development. With the additional requirement to bootstrap new modules every time, we need a programming language that can be up in about a day or even just hours. In this example, I am actually highlighting one readily available library, Fast API, which we can use quickly to set up a working endpoint. So now that we've identified the separate domains into their own services, can we now say that we've done our job at making sure our services are scalable and maintainable? Scalable for sure. Infrastructure scaling on a module level is, I believe, achieved with the current setup. We have also managed to group domains whenever appropriate. However, are our domains decoupled, or can we further improve on this setup? So this is where event-driven architecture comes into play. In our latest example, we managed to offload the actual logic to their respective APIs, but we failed to remove them on collection service completely. In event-driven architecture, as you will see in a while, we can further decouple the collection service from the other services. By doing the shift in responsibility from collection service down to the other services, we can make our flow in collections API simpler and more manageable. So in event-driven architecture, one question always comes to mind. Is the process part of the main logical flow, or is it just a side effect? So we still have this example from before. So we have all the context of sending the push notification, the SMS, and the email. We ask the two questions that we have. So what's the main logic flow? The main logic flow is just recording loans for collection. Side effects would be sending notifications, the SMS, the emails, all these things, right? And pushing to the dashboard. So with event-driven architecture, we would actually introduce a concept called event streams. The paradigm shift here starts from collection service only caring about what it does. So only caring about what matters most, and then sending that event to an event stream to notify others of what it has done. In our example, it's recording the client's loan for future collection. Now, collection service is unaware of the notification service, the dashboard service, or of any other service that wants to integrate to collection service. So this is how the new collection service will look like. So we still have the getting of clients, we still have getting the loans, we still have the main logic of recording the loans for collection. However, we stop there. We stop at the main logic of recording the loan for collection. And after that, we just send an event to our system saying, hey, we've already done our part, do whatever it is you need doing. So an example of an event would be like this. This is how events usually structured in event-driven architecture. So we provide all the data necessary to get the action done without having to call additional services again, like calling clients API again or loans API again, without veering away from the actual event that has happened. So on the notification side of things, this is what it will look like now. The main difference is that the notification service just doesn't care about simply sending emails, SMS, or push notifications anymore. It is now also responsible for managing all notifications being sent out by the system. With this design, sending notifications is now more intentional, and the notifications team has more control over what notifications to support. So no more test SMS to be sent in production. So in event-driven architecture, Python still remains to be a great choice because mainly of its community and vast number of available solutions. For RabbitMQ, we have Pika, PyRMQ, which is actually a library developed by some of our engineers. Redis, we have Redis Py, Kafka Python. To end my presentation, I just want to leave you all with one note. There will always be coupling. We just need to figure out how to manage them. So in highly complex systems, coupling will always be there. We just need to figure out when to manage them. With domain segregation and event-driven architecture, you can start to make your application scalable and maintainable. Thank you. If you want to know more about all the things we do in BillEase, please send me an email or LinkedIn. Or you can visit our booth there in front. Thank you.
Thank you so much, Joseph. We have 1 minute. Does anyone have like a very quick question? Anyone? Actually, we're out of time then. We have. Okay, one quick question. Thank you.
Yeah. I'm Alex from Salmon.
Hello.
I want to ask how you handle cases when you send event notification, but the notification actually is not sent. And how do you handle these cases?
Yeah, so I was supposed to actually add those next, which is on reliability and resilience patterns. So what we currently do is we basically do patterns like retries. In our event, we use dead letter queues, or we do retries in our HTTP request. So there are some patterns that we can use to mitigate this kind of risk when it involves asynchronous programming. So yeah.
Thanks.
Hello. Thank you so much. Thank you, Joseph.